now take on the last objective in this lesson. Let's look over here and see what it is. Your final objective in lesson 3.3 is what, Calvin?
I can find a reasonable domain and range for a function.
Okay, good. I can find a reasonable domain and range for a function. So in other words, we already know what domain and range are, don't we? What's domain? When they talk about the domain in a mathematics world, what are they?
The x-axis.
The x-axis?
Or the x values.
The x values from a relation. So you have the set of ordered pairs, they make up a relation. All the x values in that relation make up the domain, okay? What's a range then? In the mathematical world, what is a range when they say find a range? That is the what?
Y values.
Now, the y values make up the range for a relation or for a function. Well, today we're going to be writing our own functions again, but when we talk about the domain and range, we're going to say we're going to have to pick out what are those reasonable numbers that can be included in a domain and in the range, according to what's going on in this problem. Okay, so I need everybody to open their books to page 182, it looks like. Page 182 in your books. And we are going to do, it looks like it says, the check it out problem. And check it out problem number 5. So where's that at on page 182? Where's it at?
At the middle of page
About the middle of the page. It's about that think and discuss box. And below example number 5. So example number 5 sets up something that you can also use to study in your book to help you if you don't understand how to do these on your own. You can use that example to study. We're just going to go directly into practicing the check it out problem and working through it. So, I have a reader for our problem. Devontae can't find it. Devontae, what page are we supposed to be on?
I'm not sure, I'm still correcting.
182.
Do I have a volunteer to read the problem? It's loud. Cody?
The setting on the space heater are the whole numbers from 0 to 3. The total number of watts used for each setting is 500 times the setting number. Write the function and describe the number of watts used for each setting. Find the reasonable domain and range for the function.
Okay. So did they give us a set of ordered pairs? Did they give us a set of ordered pairs? No,
Yes.
we're really gonna kind of have to find them, set them up, and be able to say, okay, well could be the domain range. Well, before we even do that, we got to decide what is going to be our independent and dependent variable in this. In other words, what depends on what? What controls the situation? Remember, that's the independent variable. It's the control freak. And whatever the controller does, there's something that happens as a result of that. That's the dependent. So, what are the first of all the two kind of like things that can change in this problem? What's one of the things that can change in this problem? Okay. I have only Cody engaged is all I'm feeling like today. He's the only one speaking to me. Really? I guess it's time for me to start calling on some people because you don't want to do anything thinking you're going to let other people think for you. Okay? So, Devontae, what's one of the things that can change in this problem? Aurora. Julia. The number of watts. Now, how many watts the heater is going to kick out? Okay. What's the other thing that can change in this problem? Tori? Calvin?
Setting of time.
The setting number, yeah. Which setting are you going to put it on? So you've got the setting number. You get to choose what setting number you're going to put it on, and then we have this. How much heat is going to kick out of there in watts is the other thing that can change. So which one is going to depend on the other, or in other words, or maybe you can think of it this way: which one's going to control the situation? So would the setting number be dependent upon the number of watts that are coming out of it, Or in other words, would the number of watts control the setting number? Or would it be vice versa? Would we say, you know what, the setting number is going to control how many watts come out of it, so the number, how much heat is kicking out of that heater is dependent upon what you set it at. Which one makes more sense? Cody?
The one where you have, your setting number is the independent and then the number of watts is the dependent.
Yeah. So you know what, we're gonna say that the total number of watts, go ahead and grab a pen, you guys grab your pencil. The total number of watts, how many watts total this heater's gonna kick out at a time, depends on the setting number, those two unknowns that we identified. We gotta say which one of you gets to be the independent variable and which one is the dependent. And by making yourself talk through a statement like that, it helps you decide which one's gonna be independent, which one's gonna be dependent, instead of being flippant about it and saying, oh, just let one of them be and let the other one be the other, and who cares? So what's our dependent variable?
Number of watts.
Total number of watts. And independent,
700.
the setting number, okay. Well, we know then that once we decide which is dependent, which is independent, typically, which variable is the dependent and which variable is the independent. Doesn't always have to be this way, but typically it is. What's the dependent variable typically? The x or the y?
The dependent is the y.
That's the y. So let's put that over here. Y is going to be our dependent, and x in our function is going to be the independent, the setting number. Okay. So what's the rule? The function rule is that there's no y involved in the function rule. The function rule only has that control-free independent variable in it. So what do you think would be the function rule for this problem? Michaela, what do you think it is?
Is it like fx equals?
Okay, remember we don't need an equation. I just want to decide that what are we going to do to the x, the control free, what are we going to do to the x that will eventually get us the y? So I just need an expression. That's all I need, an expression, not an equation. Cody?
I think it should be x 500x.
500x. Why?
Because it says the total number of watts used for each setting is 500 times the setting number. So if you had, say you had your 2 times 500 is 1,000. So then you have to get your y for the 2.
So you think you can agree with them that our function rule should be 500x? Because they said take the 500 times the setting number. The setting number is x, isn't it? Okay, so our function rule is 500x. So now we know that when we do that, the result, the dependent variable y, is going to be the result. So we say, here's how you get y. Y equals 500x. Or in function notation, how would that look? F of x equals 500x, yeah. So either way, we're saying the same thing. To get the y, to get the total number of watts, here's what you do. You take 500 times the setting number. This says it like this. The function evaluated at x, whatever you put in for x, here's what you're going to get when you take 500 times that number you put in for x. It's still a dependent, it's still the result, okay? So what do you think is a reasonable domain for this one? What would be a reasonable domain for this one? In other words, what are all the, think of it this way, what are all the possible things we could substitute in for x? Aurora, I'm going to give you another chance. Go. What do you think are all the possible things we could substitute in for x? Remember what x is. It's the setting number. You want Abby to come to your rescue? Or you ready to spill it out? Abby to the rescue!
0, 1, 2, and 3.
All the setting numbers. It said this heater had setting numbers 0, 1, 0 through 3, and did it say something about whole numbers? Yeah, whole numbers from 0 to 3. So there's no 1 1/2 or 2 3/4 or anything. Okay, there's our reasonable domain. We had defined it. Okay, well then the range, oh, I guess we're not going to do that there, I'm sorry. We're going to do this, find the reasonable range. So we're going to put our x values into a table. 0, 1, 2, 3, and our function rule says take 500 times that x and you will get your y. So 500 times 0 is 0. Does that make sense that when the heater is set at 0 there would be no wattage?
Yep.
Yeah, makes sense. 500 times 1 is 500, okay? 500 times 2, we're evaluating right now. We have 4 domain values that we're evaluating to get our y values for this function. How many total watts when it's set on 2? 1,000. And 500 times 3, which is 1,500, also known as 1,500 in our world. Okay. So, we have now found our range, have we not? What is it?
0, 500, 1,000, 1,500.
Okay. So we found our reasonable domain, we found our reasonable range, but to get them, we also evaluated a whole bunch of things. We said, what's got to be dependent upon what? What's our independent? Then what's our dependent? What kind of a function rule could we write for this that will help us get those y values, write a function for it? We're practicing everything that we really have been doing in this lesson. So anybody have any parts of this that were confusing after I tried to pick on you? Any parts of that we need to go back to? I guess not. Okay, let's go to the back then. This is more practice. I don't think this one came from the book. I think this is one that I just wrote out. Okay, we got this moving company that charges $130 for truck rental plus $1.50 per mile. Okay, again, here's what I want your brain to do first. I don't even want you worrying about filling out those other things right now. I want you to tell me what are the 2 things that can change in this problem.
The total amount of money and
The
then
total cost for renting this truck.
and the per mile. Oh,
Per mile?
Total distance.
The total distance, the total number of miles. Don't we know how much it is per mile? That's not going to change. That's not something that's going to change. That's what they told us it's going to be. So the number of miles can change, how many miles you put on this truck, and what the total cost will be after you do rent it, put on some miles, and then take it back. Okay? So, identify the independent and dependent variables, write the function to describe the situation. So what's going to be dependent upon what? Are we going to say that the number of miles you drive is dependent upon the total cost? Or is the total cost going to be dependent upon the number of miles you drive? Which makes more sense? All in favor of total cost, depending on the number of miles you put on it? Absolutely, yeah. How much it's going to cost you is going to depend upon what again?
Total cost, total mile distance.
Number of miles, yeah. How many miles are you going to put on that truck? That's going to control the total cost, along with, we know there's another factor in there, but we'll make sure we put that in our function. Okay? Function rule. What's the function rule for this one? Devante? Devante's closest. Well, a lot of you are pretty close to bring Valentine colors today. Devante, what do you think the function rule is?
130 plus $1.50 X or 1.5x.
Okay, so we could put it 150, or we can leave that 0 off and make it 1.5, it doesn't matter. Okay, how many of you agree? You think that's a good function rule? Keep that? Okay, so in other words, this is what you have to do to the x that will then make it a y. But not only do you have to multiply the x by $1.50, like we found in some of our finding function rules, not only do you multiply, but then you might also add or subtract, right? So we're going to add 130 to it besides. So what's dependent upon that? What are we going to put in our equation for the dependent? What is dependent upon this function rule?
Y equals 1.5x plus 130.
Okay. Cody wants it turned around the other way. He wants the figuring out the mileage part to be first. How much it'll cost for the total number of miles. Add the $130 one-time rental fee, and you should get your y. Or in function notation, if they asked you to write it in function notation, we would replace f of x for the y. We would say y is the same as f of x, and we need to make sure that we get that planted in our heads because they use that more typically in upper level math classes. When you start taking other math classes, they will use f of x probably more than they will y. You need to understand, you need to be able to say, oh, you know what, that's not a big deal. I learned back in Algebra 1 that f of x is the same as y. Okay, what do you think are reasonable values for the domain and range in this situation? So, domain, let's start there. What do you think might be some reasonable domain values? And do you think, considering what the domain is representing, do you think we can list all of them? How do you feel about it? Think we can list them all? Give me some examples of some numbers you think are reasonable for this domain.
Well, the domain is x, and your x is number of miles, so you go 10 to 20 or 10 to 100 or
You could be crazy and just
drive.
drive it one block and then we're going to come back and return it. And that would even be 10 miles, right? Possibly. So you could put a mile on it, you could put...
So you go from 0 to 10 or 0 to 20.
Julia? All real numbers. What are the all real numbers? When we say all real numbers, what are we including? Not the negatives. Are the negatives included in the all real numbers or not?
No.
Just the positives
Just
are?
positives.
Oh.
Could it be fraction? Like,
I'm going to challenge you on that. Guess what? This number line and its continuation of it is a representation of all real numbers.
negatives are all.
Because then you can't go backwards.
You can't go backwards what?
On like negative.
No, you can't have negative distance. We wouldn't, they're, go ahead and try and convince the rental company that, you know what, I drove it backwards the whole time. And so that 30 miles I put on it is a negative 30, so now you have to give me negative 30 times $1.50 off my bill. You think they're going to do that?
Nope.
No. So you think it's all real numbers?
Nope.
Can we include those negatives?
All positive numbers.
All positive numbers.
Zero. You just do like 0 to 12.
How could we state that? How could we state 0 to Aurora? What do you think?
All real numbers except
Okay, we could write it out. We could say in words, all real numbers except the negatives. But we could do it mathematically too. We know how. Cody?
You could do 0 is less than or equal to x, which is less than or equal to 300.
So we can't put any more than 300 miles on this truck? Or isn't it a truck?
Well,
Did they say there was a limit?
no, but it's just a number. Stop at.
Does it have to be a compound inequality?
No.
What happened to simple inequalities? Did they disappear once we started studying compound inequalities?
0 is greater than or equal to x. Or x is greater than or equal to 0.
Devin Anderson, the junior to the senior high office, please.
I think Cody might have possibly just said it. Would that represent 0 Because you don't have to put any miles on, you can be crazy and go rent this truck, pay the $130, sit there in the truck for a while and pretend you're gonna use it, and then get out of the truck and not put any miles on it, couldn't you?
Yeah.
Could you do that? It'd be a crazy thing to do, but could you?
Would you
So
like-
it could start at 0, but then you also could we said it has to include just positive numbers, not negative. Would that simple inequality describe what could happen?
Yes.
Okay, good. Whew, we got it. Okay, range. What would be the result then? Remember, there's got to be a result because of what? Now, because this is an inequality, I'm thinking, you know what? We could start a table. We could go, okay, here's our x values, and our rule says take 150 times x, add 130, and presto, you will get the y. Okay. Well, let's do 0. For the fun of it, what would it be? 150. We're evaluating for 0. What's $1.50 times 0?
0.
0. What's 0 plus 130?
130.
130. Remember, this is that situation where you're going to be crazy. You're going to just not drive the truck. You're just going to go sit in it. So it's going to cost you $130. Okay. Cody?
We could do 10.
We could do 10. Okay, let's do a 10. Because that's in our domain, isn't it? Okay, let's do 10. 1.50 times 10 plus 130. $1.50 times 10 miles. How much would that cost? That part. It's $1.50 times 10.
$15.
Oh, it is $15. Why did that take so long?
Sorry, I
That's so scary. When you multiply by 10, you move the decimal point.
back one. Back two.
When you multiply, it needs to get
4.
forward, so you need to move the decimal point one place to the right. So 15. Oh my goodness, that's so scary. 15 plus 130.
145.
145. Oh my gosh, you guys seriously have got calculator mush brains. Oh, that's so scary. Okay, let's do let's do 20. Let's just do one more. What's $1.50 times 20?
$30.
$30. We just said 10 is 15. We just doubled our mileage, so we can double our 15 and we get 30. And then we still have to add the 130 to it. So
150.
how much? How about 160? Well, are those the only 3 numbers in our range then? Because those are the 3 we evaluated. So are those the only ones in our range?
No.
No. So what do you think we're going to do? How are we going to write the range?
Same way as doing, but y is greater than or equal to 0.
Y is greater than or equal to 0. Well, let's check that out. Let's see if we like that. Y is greater than or equal to 0. So in other words, in this situation, when you put the smallest domain value of 0 in, you get a range value of 0 also. Is that what happened? Well, look at here. It's staring you in the face right here. Did we get 0 for Y? Then can we start at 0?
No, we start at 130.
We got to start at 130, don't we? Yeah. We can't start at 0. And then it's going to go up from there, isn't it? That's the sit in the truck, don't take it anywhere. And then from there, the cost is just going to go up, isn't it? So there's our reasonable domain and our reasonable range. We have to think through these. We have to process through these. We can't just say, you know what, I don't want to start at 0 also. No, there's that one-time fee of the $130, whether you want to pay it or not. Okay, anybody want to discuss that anymore? Cody?
I got the answer.
Oh my goodness, really? What did you do to get the answer? I don't want to know what the answer is. I want to know what you did to get it, though.
Okay, I did the same thing on top. I did the 200.
Oh, so you made kind of like you added 200 in the table?
Yeah.
Oh, that's a good thought. Okay, so
And I did
1.50 times x plus 130, and you're going to let 200 be your x value you're going to evaluate, okay? And then, so you put that in for x?
Yeah.
And without a calculator, right? Cody,
Yeah.
you figured out what $1.50 times 200 is?
Yeah.
Good job, what is it?
It was
Oh, okay, there's an easy way to do this. Let's all do it together. $1.50 times 200. Engage your brain, because I'm trying to take a little bit of that mush and firm it up for you. Okay?
300.
Thanks, Cody. But everybody be with me. $1.50 times 200. What's 200 times a dollar? $200. You got a dollar 200 times, that's $200, right? 50 cents is half of a dollar. What's half of 200?
150.
100. What's 200 plus 100?
300.
Oh my goodness, see how easy that is to do? We do not need to, use a calculator. 300 plus 130 is?
430.
Okay, we're gonna just show this right here, that we got 300 for this. We're gonna add 130, and we're gonna say that the Y value is 430. How much will it cost if you rent a truck for 200 miles? We're gonna answer that in a sentence. Okay, who wants to offer up the sentence? Oh no, Cody, you need to rest your little words for a while. Thanks, though, but thanks for offering. Calvin, feel free to fill me in here. Sentence answer. How much will it cost if you rent a truck for 200 miles? Let me get that I out of there, because you get to.
The cost to rent a truck, the truck,
The cost to rent the truck. Oops, I need a rent in there. Go ahead, you can.
is $430.
The cost to rent the truck for 200 miles?
Yep.
And the only thing I'd let you not write out in words is the number, and we don't abbreviate in sentences. The cost to rent the truck for 200 miles is $430, and I'll let you use the dollar sign for that, $430. We are good. Questions? Complaints? Concerns? Okay, there's your homework over there, go ahead and get started.